Okay, let's just jump right in. If you're looking at a modern web framework like Laravel for the very first time, I know it is incredibly easy to feel totally overwhelmed by the sheer barrage of files and folders. But hey, take a deep breath. Today, we're skipping all the complex setup and the dense technical jargon. Think of me as your technical mentor. Together, we are going to map out the really elegant journey of a single web request.
To really get this, we need to ask a pretty fundamental question: what actually happens when you hit that submit button? Well, think of a web request like a traveler. This traveler is arriving at the front doors of an elite, super well-run restaurant, and they've got one simple goal: to hand in their order ticket. Now, maybe that ticket is a request to log in, maybe it's a brand new blog post they just typed up, or maybe they just want to view the daily menu. Whatever it is, they're standing at the door, data in hand, fully expecting a result.
Back in the Wild West days of the early web, this traveler might have just walked into a totally chaotic kitchen where one single person was trying to take the order, cook the food, and seat the guests all at the exact same time. It was a complete mess. To process this request without that kind of chaos, a modern framework relies on a highly coordinated team using a pattern called MVC. That stands for models, views, and controllers. Each one of these components has a very distinct, specialized role to play in your project to make sure our traveler has an absolutely perfect experience. So let's meet the team.
The very first face our traveler sees isn't actually part of the MVC trio, but they are absolutely crucial: the route. Think of the route as the maitre d' of our restaurant. When the traveler walks in, the maitre d' takes a look at the requested URL. Are they asking for the login page, the create post page? The route takes one glance at that URL pattern and says, yep, I know exactly who handles this, and hands the traveler off to the right team member. And right here is where the controller steps in. The controller is basically our waiter. They take that order ticket from the traveler and figure out exactly what needs to be done. Do we need to check if this person is of age? Do we need to go grab specific ingredients? The controller coordinates the whole shebang, making sure all the rules are followed before anything actually gets cooked up. Once the waiter knows what's needed, they head straight to the back. Enter the model. The model is your kitchen. Actually, scratch that. It's more like the head chef and the kitchen combined. It's the absolute bridge to your actual database. See, the framework has no clue what a user or a blog post is until you define a model for it. The model maps out the exact shape of your data and does all the heavy lifting of grabbing stuff from the pantry, your database, and writing new records safely. Finally, once the kitchen has cooked up all the data, they hand it back to the waiter, our controller. But, we can't just slap raw ingredients down on the table. It needs to look good. That is exactly where the view comes in. The view is the beautifully plated meal. It's the HTML, the styling, the actual visual web page that finally gets delivered back to our traveler's screen. So, when we piece it all together, we get this really cohesive map. Step 1, the maitre d', the root, receives the request. Step 2, the waiter, the controller, gathers the data and checks the rules. Step 3, the kitchen, the model, interacts with the database to get or save the information. And step 4, that plated meal, the view, is displayed right back to the user. It's literally a seamless, highly organized relay race. Now, the real magic happens when we translate our conceptual kitchen into actual persistent storage. We keep talking about saving things, but where do they actually go? Well, your database is the restaurant's pantry, and inside that pantry are different shelves, which we call tables. The framework uses this brilliant automated system to map your models directly to these database tables.
Think about an actual shelf in this pantry. A database model maps data straight to a table. Let's say we have some blog posts, right? How do we know who wrote them? Well, this is the magic of relationships. Instead of storing the user's full name on every single post they write, we just link a specific user to their own unique records via a simple ID number. So user number 2 wrote the first couple of posts, and user number 3 wrote another one. It keeps the data incredibly clean and tightly organized. But hey, our kitchen isn't just about storage, it's heavily about rules. The model acts like a bouncer for your database. One of the coolest ways it does this is by enforcing a strict fillable array. This tells the system exactly which fields a user is actually allowed to fill out. If some bad actor tries to maliciously inject data to magically make themselves an admin, the model checks the fillable array, sees that admin is not on the VIP list, and just completely ignores it. It's built-in peace of mind for you.
Speaking of peace of mind, let's talk about the front doors of our restaurant. How does our establishment keep out the malicious actors while simultaneously rolling out the red carpet for its VIP logged-in customers? Security in web development used to be a massive headache to set up manually, but a modern framework? It handles the heavy lifting for you automatically.
Take form submissions, for example.
When a user submits data, how do we know for sure it actually came from our website and not some hacker trying to forge a request from a totally different site? The framework automatically protects user input using something called a CSRF token. Just think of it as a secret handshake. Every single time a form is generated on your site, it includes this hidden, unique token. When the form comes back, the MitraD checks it. No secret handshake, the door stays shut. No exceptions.
Now, what about when a user successfully logs in? It would be terribly annoying if they had to prove who they were every single time they clicked a new link. So, once logged in, the system manages user sessions. It creates a persistent memory, like a VIP pass, that holds their ID. This allows the restaurant to instantly recognize them on every subsequent visit, serving up their own personal data, right up until they explicitly decide to log out and hand back that VIP pass.
And listen, there is an absolute golden rule in web development. Never ever store plain text passwords in your database. If someone broke into your pantry, they'd have everyone's actual passwords, which is literally a developer's worst nightmare. The framework handles this gracefully right out of the box by mathematically hashing them with super secure tools like bcrypt. By the time that password actually reaches the database table, it's just a scrambled, completely irreversible string of gibberish.
As your mentor here, I really want to leave you with some crucial advice. Future you will absolutely thank current you for recognizing some common pitfalls right now while you're learning how this framework handles data. It's super easy to get excited and just start building, but keeping a few basic best practices in your back pocket will save you hours of debugging headaches down the road.
Okay, rapid-fire pro tips. First, never skip your CSRF tokens on forms. It is a one-line addition that keeps you totally secure. Second, always hash those passwords before they hit the database. Third, really lean on those model relationships, like linking a user to a post, so you avoid writing complex, messy SQL queries yourself. Let the framework do the heavy lifting. And finally, when you're testing and your database becomes a messy disaster of sample data, don't delete rows manually. Just use the migrate fresh command to wipe your tables completely clean and start fresh. It is a total lifesaver. Just please don't ever run that command on your live production server unless you want to be updating your resume by the end of the day. Understanding this whole underlying journey, it completely takes the mystery out of web requests. You now know exactly how a simple form submission travels through the route, to the controller, into the model, and beautifully back out through a view. Which leaves us with one final, very exciting question for you. Armed with this knowledge, what are you going to build next?